Assalamu alaikum, dear students. This is our second online class, and basically week 6 of the subject basic electronics. Last time we studied some basics of electric circuits, which we have earlier done in our face-to-face classes at UT Peshawar. So I think most of the stuff we have covered has also covered the basics of electric circuits and all the necessary things which are required for this course. So later on, whatever we will be needing, I will cover that step by step. Today we are going to start another very important topic of electronics, and that is the semiconductor diode. So what is basically a semiconductor diode? Semiconductor diode can be seen here in this diagram. So this diode is a two-terminal device. Basically, this is a two-terminal non-linear device which allows current in one direction, but it simultaneously blocks the current from the other direction. Not simultaneously, but when polarity of the applied voltage is reversed, there is a separate term for this mechanism, which we will be doing later on. So when polarity is applied in one direction, it will be conducting like a short circuit, and when the polarity is reversed, it will completely block the current. Just like nowadays, you guys have been seeing on the roads in Peshawar that wherever police or our local administration wants to make a road one way, they install braces at at the entrances of the road. So in that way, they can block a road in one direction while traffic can be passed from the other direction. So same mechanism is applied here in this electronic device, where current will be flowing in one direction while the reverse flow of the current will not be allowed. Let me draw it again. Uh, this when while the red direction is not acceptable. Okay, so it will allow it in this direction, and this is basically a non-linear device. Why is it called a non-linear device? We will be seeing in the next section. So you can see that when certain polarity like positive is applied here and negative is applied here, so the diode will be conducting will be acting like a conducting wire, and it will be represented as a short circuit in ideal circumstances. Okay, ideally we consider that it doesn't have any resistance, so that's why we will be considering it as a short circuit. Similarly, when the polarity of the voltage is reversed, you can see it here. So when the polarity is reversed, this diode will act like an open circuit, which is shown here, and no current will be flowing through this wire or these connection. So the diode will be acting like an open circuit. So these are basically the two scenarios which will be termed as the biasing. Okay, when biasing, but before biasing, let us give name to the two terminals of this diode. So these two terminals, one is this one and the other one is this one. This terminal is termed as the anode of a diode. Excuse me for my writing because I am using a touchpad here. This is called the anode, this terminal, while the other terminal, this terminal, this is called cathode. We have covered most of the things in our class, but I am repeating those things because we will be using the diode very often in this course. Okay, anode is represented by A, while cathode is represented by K. So these are basically the two terminals, and when we will apply a voltage here, okay, when we will apply voltage here, like here we have a diode. When we apply voltage, like here we are applying positive, and negative terminal is connected with the cathode of this diode, so current will be flowing through this diode like this one, and circuit will be a and it will be just like the complete circuit, and here it this diode will be acting like a short circuit. Okay, but as the polarity this okay, this thing here, now this is called forward biasing. This is a biasing technique. What is a biasing? When we apply the voltage source to any device, this is called biasing. This is a direct current voltage source, DC source. So we are applying it to a semiconductor diode. So that's why this is called a DC biasing. Similarly, when we apply, okay, let us mm, write again. When we will apply opposite of what we have done earlier, this and this. So this is now positive and this is negative. So when this is the scenario, so now you can see that the anode is connected with the negative terminal, while cathode is connected with the positive terminal. Okay. So as the biasing is now reversed, so that's why this diode will not be a conducting one. It will react like this circuit, this one. It will be an open circuit and no current will be flowing through this diode, and this scenario is called reverse biasing. Okay, in reverse biasing, we will not be having any current flowing through this diode in ideal condition. In ideal condition, this diode will be acting like a an open circuit. Okay, so I think it is now understandable. So this is a diode. These are the characteristics in a broad term. We will be discussing it in very detail in some later slides. But this is the thing which you guys should have in your mind before progressing in this subject. That diode is like an open like a unidirectional device. Okay, let's move on. So what are the characteristics of a diode? We have seen all those characteristics in the later slide uh, when we were discussing a diode. Um, Basically, it has two regions. One is a conduction region and the other one is the non-conduction region. So conduction region is basically the forward biasing region, forward biasing region, while non-conduction region is a reverse biasing region. Reverse. Okay, these are the forward and reverse biasing region. These are biasing region. You can also see it here that in this region, when this is a first quadrant, in first quadrant both P of D and I of D are positive. Okay, but here when this is a non-conduction region, so we have the second quadrant, and second quadrant V is negative. This V is negative while ID is positive. So in construction region, in conduction region, we can see that the voltage across the diode is 0 volts. Okay, in ideal conditions. In ideal condition, when the diode is conducting, so it will be a short circuit, and the voltage drop across a short circuit is always 0 volts. Current is infinite through any short circuit current is also infinite, while in reverse direction. In reverse direction, all of the voltage across the diode, all of the voltage across the diode, because the voltage, because now the diode is behaving like an open circuit, so all the voltage is dropping across that one, and as the diode is an open circuit, so there is no current flowing in this direction, which we have seen in the earlier slide. The forward resistance defined as this one. Okay, as I have already told you guys that in any electric circuit element, you have three quantities, or you have three things in your hand, which are the voltage, current, and impedance, or the resistance in DC terms. So if you want to find out any one of these things, you should be having any two of these any two of these three unknowns. Okay, so now if I want to find out the value of this resistance or the forward resistance of any diode, which is not the ideal case, if we don't have an ideal case, so I should have the voltage drop across the diode and current flowing through that diode. Similar is the case here. Okay, so in which scenario the resistance will be higher? Here the resistance will be very higher. Okay, because in ideal case the resistance will be infinite, but in real cases the resistance will have some value, but very higher than this. Okay, the diode act like a short circuit and the diode act like an open circuit. These two are basically the ideal cases for the ideal diode. Okay, in these two cases, the diode will be the short circuit and open circuit. Okay, so now I think it's understandable. Okay, uh, when we talk about the semiconductor materials which are used in diode construction, basically we have three semiconductor materials which are mostly used. The first one is a silicon, the other one is a germanium, and the third one is a gallium arsenide. Okay, what why we are not using certain element for the other application, and why we are not using a one which we have made for the first application, it depends upon the application or the device you guys have been making. Okay, there are many things which we have to consider while designing any circuit, and those things can be the speed, the switch, the voltage, and power consumption, so on. These are the things which you should be considering while designing any circuit. So these three materials are based on the requirement will be they are based on the requirements which you will have in your mind while designing any circuit. So silicon, germanium, and gallium arsenide. These are the three materials. Okay. So doping, what is basically doping? You have two types of materials and type materials and p-type semiconductor materials. So in order to increase the conduction of any type of material, we use doping. In doping, you will increase the amount of current, amount of electrons in n-type material, and an amount of positive charge holes in a p-type material. This is just like the this is like the internal structure of a semiconductor material. So these are the things you guys should read by yourself, because these are the things you have seen in your FSC and so on. I'm not going in detail of these things, but doping is a process in which we increase the conductivity of a material. Okay. Uh, PN junction. What is a PN junction? When we connect two type of materials, and type of material and p type of material, there is a region between uh, these materials. That region is called a PN junction. Why is this called a junction? Because there is no charge and or we can say that this region is a neutral region. Okay, so that's why this is called a p junction. P junction is again shown here that when we are making a when we are making a diode, so we will be having a an n-type material, a p-type material. Okay, we have two type of materials, and there what is this? This is a region which is called a depletion region or p junction. Why is it called a depletion region? Because it is depleted of the free charges. There is no free charge here. When we have connected to freely two material having free charge, one has uh, holes in it and the other one has electrons in it, and you are connecting them. Here you will be having another region which is depleted of all the charges, and this thing or this part is called, this region is called the depletion region. Okay, as it is written here. Okay, let's move on. Um, what are the basic conditions for operating a diode? As you can see, the diode is an electronic device, or for any electronic device or any electrical device, what you guys will be needing is the is basically switching on the device. Okay, if you want to make bread, or if you want to cook something in your oven, what will you be needing? And in the first step, you should have to uh, start the oven by giving it a power supply. So for operating the diode, you will also have three conditions in which, in first condition, you are not applying any voltage. In second condition, you are applying the forward biasing. I have told you guys that I have taught you guys that what is by forward biasing, and there is a third condition in which you are reversing the polarity of the battery which you have applied in forward biasing, and that is called the reverse biasing. These are the three conditions we will be seeing uh, stepwise. Okay, so this is the first condition where you are not applying any external voltage source. So if you are not applying anything, there will be no current in it. You can see that you are not applying any voltage. So the value, the amount of current will also be zero, and there is no, you can see that there is no voltage here. Okay, so very small depletion region will be here, and the device will be like an idle device or idle thing. Here it will be. Okay, so let's move on. This is another this is another condition. That's for C squared forward bias. This is another condition which is called, which is the forward biasing. In forward biasing, you apply positive voltage here and negative here. Okay, and for the region, for this reason, by applying positive here and negative here, as we are considering the conventional current, so all positive charges will rush towards this terminal. So when all will be rushed toward this one, the depletion region will be broken. Okay, it will break all the depletion region because positive charges are coming rushing towards this direction. So when these will be rushing here, depletion region will be broken, and one time there will be a time when all the current will flow in this direction, and so it will be conducting like a short circuit. Okay, so this is the forward bias condition in which the p junction will be broken and all the current will be flowing here by applying the forward bias mechanism. Here we have a term which is called the majority carrier. majority carriers are here in this scenario are holes or positive charges. These are the majority carriers because we are now here applying the positive voltage. So positive carrier are the majority carriers. Okay. So there is also another condition which is called reverse biasing. Reverse biasing to apply negative terminal here and connect positive terminal here to this is positive terminal is connected with a cathode. Okay, and negative terminal is connected with this anode. Okay, so when these terminals are connected, negative is here, positive is here, and we also know that here majority of the carriers are positive. So positive carriers will be pushed towards this terminal because this is negative, and negative positive has the attraction. So all the positive poles will be rushed here, and so we will have current direction, current in this direction. All the current will be flowing in this direction, which is the reverse direction. And in this case, we will have minority carrier, and all current will be here this direction, which will be very small in amount. Okay, that's why this is called reverse current, leakage current, or the minority carrier flow. Okay, in this case, the depletion, the size of the depletion region will be increased. Okay, so you can ask me that if the size of the depletion region is increased, how come the current is flowing? So current will be flowed by the charges which are available here at these points. Okay, at this surface there will be some charge. So due to these charges, the current will be flowing in this direction. Okay, so in this way the current will be flowing here. So let's move on. Okay, the diode characteristics, I have told you earlier that diode is a non-linear device. So as the diode is a non-linear device, you can see that the characteristics of the diode will be non-linear. What is meant by non-linear? You have earlier studied a well-known law which is called Ohm's law. What is Ohm's law? Ohm's law tells you that if you have a voltage here and current here, and you are increasing the amount of voltage by keeping the resistance constant, so the voltage, by increasing the voltage across the resistance, the cross, the amount of current will be increasing in an exponential manner. Okay, in an exponential manner, the current will be increasing. And similarly, here you can see that these are basically two different curves. I will be discussing it in the next video. I have to pause it here, and when we will come again, I will be discussing it. Thank you so much.